Hey everyone, welcome back to my YouTube channel. As you all know, I'm Venkat, a third sem student from Sri Venkateshwara College of Engineering, Bangalore. Today, let's discuss the topic K-Map from Digital Design and Computer Organization. K-Map is also known as Karnaugh map. The agenda of today's topic is its abstract introduction, the purpose of using K-Map, the structure of K-Map, types of K-Map, filling of K-Map, grouping of K-Map, disadvantages of using a K-Map. First, let's know its abstract. The K-map is also known as the Karnaugh map, which was proposed by Maurice Karnaugh, a telecommunication engineer at Bell Laboratories in 1953. Realization of the expression having two or three variables is what this paper aims at. Systematic way of representing and labeling a K-map is also discussed in this paper. Further, it mentions the properties of K-map which should be used while carrying out sum of minterms, sum of products, and products of maxims, product of sums, and logic expression. Introduction. As digital systems become more complex, the need for efficient circuit designs grows. K-map allows engineers and designers to quickly identify opportunities to reduce the number of gates and components needed, ultimately leading to simpler, more cost-effective and reliable electronic systems. In this presentation, we will explore the structure and operation of K-map, the process of grouping ones to simplify expressions, and the practical applications of this technique in digital design. By the end, you will have a clear understanding of how K-maps can enhance your ability to design efficient digital circuits. Now, let's know what is a K-map. A Karnaugh map is a graphical tool used in digital logic design to simplify Boolean expression. It provides a visual representation of the truth table, making it easier to identify common factors and simplify the expression. Here, this is a four variable K map A, B, and C, D. Here, for AB, the values are represented as 0, 0, 0, 1, 1, 1, and 1, 0, and for CD, 0, 0, 0, 1, and 1, 1, and 1 zeros. Here, the X represents it doesn't care conditions. Now, let's know the purpose of using K-maps. Simplification of Boolean functions. K-map allow for the systematic reduction of complex Boolean expressions by visually identifying common terms, thereby minimizing the number of variables involved. Reduction of logic gates. By simplifying Boolean functions, K-maps helps reduce the number of gates required in a circuit. This can lead to lower cost, less power consumption, and smaller physical circuit sizes. Easy visualization. K-maps provides a graphical method to visualize combinations of input and their corresponding outputs. This helps engineers quickly identify patterns and relationships that may not be as apparent through algebraic manipulations. Efficient grouping. K-maps facilitates the grouping of adjacent cells containing ones that are true outputs and zeros that are false outputs. This grouping process is straightforward, enabling the identification of simplified product term that represent the original logic function. Now let's know the structure of K-map. Dimensions. K-maps are typically structured as a grid with the number of rows and columns depending on the number of variables. For two variables, we have 2x2 grid that consists of 4 cells. For 3 variables, we have 2 into 4 grid that consists of 8 cells. For 4 variables, we have 4 into 4 grids, 16 cells. For 5 variables, we have 4 variable K-maps, 2 4 variable K-maps that consist of 32 cells. For 6 variables, we have 4 variable K-map that consists of 64 cells in total. For here, these are the representations of the K-maps. The first one is a 2 variable K-map which consists of AB, 0, 1 and 0, 1. They are used for the representation of rows and columns. Here, in 3 variable K-map, we are having a total of 8 cells. 8 cells were of A, B and C. Whereas a 4 variable K-map has consists of 16 cells with the values of 0, 1, 2, 3, 4, 5. Where AB and CD is used for the representation, where AB consists of 0, 0, 0, 1, 1, 1, 1, 0, and CD consists of 0, 0, 0, 1, 1, 1, and 1, 0 for the representations of the cell. Now, let's know the filling of K-map. To fill a K-map, the output values of the Boolean functions are placed in a corresponding cells. Cells are filled with 1s for minterms and 0 for maxterms based on the truth table. The visual representation aids in identifying patterns for simplification. Now let's know the grouping of K-map. Groups can be of any size, but the number of cells in a group must be a power of 2. 1, 2, 4, 8, 16. Adjacency. Cells are considered adjacent if they share a common side. In a K-map, the top and bottom rows, as well as the left and right columns, are considered adjacent. Wrapping. Wrapping cells can wrap around the edges of the K-map. For example, the top cell of a column is adjacent to the bottom cell of the same column. Here in this K-maps, uh, for in two variable K-maps, this 1 and 1, it forms a pair, which is a correct way to do a grouping. And in another example for a two variable K-map, here one it forms a squad, and even this is a correct representation. And this is a wrong representation, as it's not a as it is not divisible by, or it's not the power of 2, and a trio cannot be, a group of 3 cannot be a K-map, cannot be representation in a K-map. And even and here we can even do the groups, or like overlap. If there is a case of overlapping of groups, then even it is possible. And here this 1 1 and 1 1 can be overlap, can form a quad by using paper cutting method, and even this can form a quad. Now let's know the disadvantages of using a K-map. Complexity for large expressions, limited to a few variables, manual process, don't care conditions. Thanks for watching. If you like this video, please do like, share and subscribe. Thank you.